Today we're going to go through a couple of things. First off, we need to talk about the schedule. So the schedule moving forward for this week. Tomorrow, you are going to go through and work on your quiz, okay, for this unit. We're going to go through a number of different things today, but the primary thing that we're going to be looking at is waves, okay? So we're going to basically talk about waves today. We're going to talk about how to find all the formulas that you need, okay, from the reference table, and then you guys are going to have the opportunity to make sure that you get caught up on work, okay? So remember, and I put it on here several times, your discussions and chats count towards a weekly grade. If you're not doing it, you know, it's not something that I'm going to beg you to do. You're just going to not get credit for it, okay? So it is definitely going to be something that you need to make sure that you're paying attention to, all right? And if you do, fantastic. If not, you already know what's going to happen uh, with regards to your grade. Okay, so also I have submitted a question to Ms. Bracy about whether or not, not whether or not, but like what we have specifically for um, like possibilities if you did not get the email that you were supposed to get for the um, registration for whether or not you're going to be remote or in person. Okay, remember that you have until November the 30th to do that. If you did not get it, you need to check your clutter. You need to check your junk in your email so that you can potentially make sure that you get that stuff done on time. Okay, you got till November the 30th. So like I said, tomorrow is going to be a quiz. So when we come in, we will basically do our quiz, and then at that point, you guys will have an after test or after quiz activity that we're going to work on. All right. Ideally, today we're going to have basically a little bit of information. We're going to tie that information into the stuff that we've already learned. Okay, and we are going to kind of go through and make sure that we understand what it is that we've gone over and what's going to be coming up on your quiz tomorrow. Okay, so today's is two parts. Okay, today's discussion is two parts, or chat discussion anyway. The first one is you were instructed to tell me three things that you believe is going to come up on the test. Okay, and so like I said, our participation in that was pretty bad. Okay, so I'm probably going to skip what I did for second period, which is go through and look at a really good summary of all of that information. Okay, so based on that, you guys can go back and watch this. Okay, on the YouTube if you choose. Okay, the first part of it, and the end I actually accidentally let it run, but because the difference between their class and your class is that you are, as of right now, not putting forth the same effort with regards to review. So the let me change this. I keep telling you it's not supposed to be private. There we go. Okay. Why is it private? All right, I'll have to change it in a second. But the point of this is that we got to make sure that we are how the heck? I'll change it in a minute. I'll try to change it. We got to make sure that we're putting forth that effort. Okay, so tomorrow on the quiz, we're going to basically go through and look at the stuff that we've gone over. Okay, we've talked about force. Okay, we've talked about a number of different things. Okay, so what you guys have gone over in general, we'll look at work, okay, force, forces, okay, power, okay, mechanical advantage, all right, simple machines, and what am I forgetting? Oh, kinetic energy, potential energy, okay, and that sort of thing. So what we're going to be able to do is ideally we're going to be able to figure out all of these different things. Okay, and we've gone through and practiced a lot of this. Okay, work, you already know, is force times distance. How much force you put in over a certain distance. When we talk about forces, we talked about the fact that there are 4 different ones that we're going to deal with. You have gravitational, let me make that actually a G. Gravitational, applied, okay, frictional force, and the last one, gravitational applied. What the heck? Let me come back to that. I don't even remember what the other one is. So, and with power, you have work over time, how much energy you put in over time. Okay, and I'm going to show you where to find all of these. Okay, it is very simple to do, very simple to go through and look at. Okay, this is bothering me. Oh, and normal force, duh. Okay, so the normal force is what is basically resisting the force of gravity, and that's what we talked about. Okay, mechanical advantage. We talked about how much mechanical advantage certain machines give you. Okay, so certain machines give you more or less mechanical advantage. All right, and the higher the number, the better the machine is in terms of its efficiency. Okay, we talked about simple machines, okay, and what they can be. There's a lot of different possibilities for that. All right, and also we talked about kinetic and potential energy. Okay, when we talked about potential energy, we talked about the fact that it's mass, its gravity, and its height. Okay, and our gravity, our acceleration due to gravity on Earth is 9.8 meters per second. Okay, so you can always calculate how much energy you have from that. Okay, kinetic energy is 1/2 mv squared, mass times velocity. Okay, and we also talked about that. Okay, so it is a setup for us to make sure that we have a pretty decent understanding of all of these different things. Okay, now I did that out of the kindness of my heart, even though y'all didn't do what I asked. Okay, because we kind of need to have a little bit of a synopsis of what it is that you are going to be looking at for your quiz tomorrow. Now, when you look on your reference table, the very first thing you're going to see, you see velocity. Okay, you see uniform acceleration, those sorts of things. We haven't talked about them in this unit, but they're still pretty important. Okay, but you also have a lot of different stuff here. Okay, you have force equals mass times acceleration. Really, really, really important. Okay, the force of gravity, or basically how much you weigh, is basically determined by mass times how much gravity there is. Okay, we've talked about that. The only one we haven't talked about is momentum. Okay, and we're going to talk about momentum and inertia later. Okay, work equals force over the change in distance. Okay, times the change in distance, excuse me. Okay, and then you have P, which is power, uppercase P, is work over time. We know this stuff. However, it's really, really, really good to see that you can have all of these equations at your fingertips, basically. You have to just know how to do them. Okay, you got to know how to plug stuff in. It even gives you the acceleration due to gravity. It even gives you the 9.8 meters per second per second. That's crazy. Okay, you have kinetic energy. Stop doing that. You have kinetic energy. You have potential energy. What we just talked about: mass and velocity, mass and height. Okay. Then you have the ideal mechanical advantage. Okay, and it even tells you what DE and all that stuff is. Okay, so the resistance and the energy that you put into it, okay, or effort, excuse me, and then you have the actual mechanical advantage, the force of resistance, the force of effort. Okay, so this type of thing is going to be very easy to go through and look at. but you got to make sure that you understand it. Okay? Efficiency is even on here. Okay? The thing we're going to do today is right here, which is the wave velocity is F times lambda. Okay? Which is frequency times wavelength. Okay? So you basically have, and we haven't gone over electricity yet, but you basically have everything that you need right at your fingertips. Okay? So the setup is very simple. Okay? The setup is very easy, and it is going to be something that you need to go through and look at. All right? So at the end of the day today, your discussion is going to be basically a pretty decent setup with regards to this. Now, the chat, okay, is where you should have put the 3 topics that you already have. If you haven't done that yet, you need to do it. Now, the secondary thing, okay, is that you need to tell me what kind of questions could potentially be asked about these things. Okay, so if you said work, what kind of question could I ask you about work? All right, and it's going to be something that's very important for you to be able to go through and do. All right, now, this video today is very, very, very interesting. Okay, it's going to be talking about waves, specifically mechanical waves. All right, and we are basically going to be able to go through and look at this and see that they do a lot of really cool stuff. Okay, so we are going to go through this type of setup and this type of situation, and then you guys are going to have the independent time to work on that. Okay, now sorry, I just got a really ridiculous email. All right, so today we're going to talk about waves. Okay, and when we go through here, the setup is pretty simple, pretty easy. Okay, the setup is that waves can be mechanical or energy based. Okay, so what you're going to be able to see is some waves carry matter, some waves do not. Okay, and so everybody's seen pictures of that. All right, and the setup for us is going to be really pretty simple. Okay, mechanical waves are going through objects, going through things, going through all this. Okay, and the medium is what they are going through. All right, so the medium is something like air. All right, sound is an example. So the sound that comes from me that goes into the computer, that the computer then generates, okay, and sends to you is basically going through the air. Now, the electromagnetic waves, your computer is a combination of both. Okay, your computer is a combination of both. And so they don't need a medium, all right, but we are going through and looking at the setup for this stuff, okay, and they can fly through space. So the light that comes from your computer is not exactly flying and having to touch particles and this and that. It can just go where it wants. Okay, it's kind of cool. So mechanical waves are basically things that are going to cause you, and those battle ropes are the worst. They really tire you out. Okay, but they're going to go this way or this way. All right, this way or this way. Okay, and so this type of setup is pretty good for us to understand these different things. Okay. Now, with this, we're going to see that we have a number of different possibilities. Okay, the first possibility, here's obviously a mechanical wave. They're rolling. It's pretty cool. Okay, you have what is called a crest and a trough. Now, the setup for this is pretty easy. Okay, and basically what you're going to look at is that the trough is at the bottom. Okay, so you have like farm animals and things. If you feed them, they eat out of a trough. It's basically the lowest part. Okay, and crest is the top of it for the most part. All right, so when you look, okay, you all should already know all of this. This is a review from Earth Science. Okay, and so the good news for us is that wavelength is going to be something that we're studying a little bit more. All right, the higher the wavelength or the longer, the lower the frequency. Okay, so it's kind of cool to understand and look at that you are generating, when you talk, you are generating a sound, okay, that is dependent on the wavelength, the distance between these two waves here, okay, to basically be high pitched or low pitched. Now, if you were to have something like this with a shorter wavelength, okay, it would be a higher frequency versus, all right. And so what we're going to be able to see is wavelength is directly related to the sounds that you hear or the color of light that you see or a number of these different things. It's pretty interesting. So the other thing is the amplitude, okay? And that's basically how much power it has, okay? Its volume almost, okay? And for those of you who are interested in sounds and creating music and things like that, it is something that is really going to be beneficial for you to understand how sound works specifically, okay? Now, mechanical waves, okay? And hopefully now we don't have to deal with this individual in the PowerPoint anymore, but compressional waves is what we're going to be talking about with regards to sound. So realistically, what's happening is I am causing waves to happen, and they are going, okay? And so what the situation is that the compression that happens, okay, if you push on something or whatever, it's a compression, is causing them to move in a specific direction. Okay, this is what sound waves look like. Okay, and you go in and it comes, in and it comes together, in and it comes together. Okay, and that compression is what moves through the air. That's what happens. And that's why sound moves even more through water. Okay, so when you look at this, you can kind of tell where the compressions are. And ordinarily, we would play with slinkies. Okay, ordinarily, we would play with slinkies. And so with this, you are going to basically be able to have a kind of an understanding where if you push it, as you push it, it's going kind of like that and going back and forth. Okay, so it's pressing. And so what you can see is if this were a slinky, you can basically see where it gets squished together a little bit. All right, that's the type of a wave that we're looking at. Now, we don't care about that, and we don't care about that. Okay, the last thing that we're going to look at with wavelength before we actually do some stuff with it is we are going to basically go through and look at the oops, sorry. Darn it. Wavelength is represented by what is called lambda. Okay, lambda is a Greek letter, okay, and it is basically what we're going to look at here. All right, so whenever we see lambda, we should automatically just think of wavelength. That's the symbol for it. Okay, so check this out. Wave speed, the V, which you could look at as velocity. Okay, and in your reference table, we saw that it said V sub VW. Okay, you are going to look at and see that it basically is the frequency times the wavelength. Okay, and so your triangle is going to look like this. Okay, with the V on the top, an F, and then your wavelength. Okay, VF wavelength. Whoops. Hold on a second. All right, so what you'll be able to look at it and see is that you are going to be able to go through and identify these different things here. Okay, and so when you see, I know I've been saying see a lot, there's all kinds of notifications. The little blue guy I think is funny. Doink, 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 doink. Okay, when we look at this and we practice, let me put I did not do a good job last period of putting a color that people can see. Let's use this one. Okay, so what you're going to see is you have this, you got V on the top, you got F on the bottom, you got lambda on the bottom. Okay, so all you're doing with this is basically going in and putting your stuff in there. Now, the thing we have never seen before is this. That HZ, that is hertz. Okay, and hertz is the unit for frequency. So if you have a lot of hertz, it's very, 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 okay, if you have very few hertz, it's going to be very deep, okay? So when you look at this, it's asking you in this first one, wavelength. If you cross that one out, okay, then you can see that you have speed divided by frequency, okay? So in this case, you have 16 divided by 0.4, which actually gives you 40 meters, okay? And we'll talk about it, but it's actually nanometers, which is really, really, really small, okay? But this is kind of what we're looking at. Now, you will need to be able to do this tomorrow. However, the reason we're kind of going over it is it's basically some of the similar things that we've already done. Okay, when we did work equals force times distance, it was this exact thing, basically. Okay, it's just a little bit different because you're using different variables. Try to get this, stop doing that. There we go. So, what is the speed of a wavelength, or excuse me, what is the speed of a wave, that's supposed to be wave, that has a wavelength of 6 meters and a frequency of 3 hertz. So in this case, you would cross out the top and you would say 3 times 6, and you would get 18 meters per second. Okay, super easy. Yeah, these numbers are a little bit easy to just so you can see the trend, but it's basically what we're going to be looking at. Now, the third one, it says what is the frequency? So you scratch out or whatever, cross out frequency, okay? And you say velocity divided by frequency, okay? And so 21 meters per second is speed, okay? We have to know what speed is, we have to know what distance is, and we have to know basically what force and frequency are, okay? And if that's something we need to talk about when you guys have your independent time, 100% we can get that done, okay? So 21 meters per second divided by 7 meters, you are going to get 3 hertz, okay? Pretty simple. The last one, whoops, wrong thing. There we go, okay? The last one, it says, what is the wavelength of a wave with a frequency of 5 hertz traveling at 15 meters per second? Okay, so what is the wavelength? We're looking for lambda, and you go 15 divided by 5 gives you 3 meters. Super, super, super easy, okay? But it's got to be something that you know how to apply to it, okay? And again, all these formulas are on your reference table. Easy, okay? All you're doing is plugging stuff in, okay? Now, we're almost done with waves. This is actually really cool, and I wish we could spend more time on it. We can maybe spend more time on it later, but for right now, we're just going through it. So, when a wave strikes an object and bounces off of it, it is going to be a reflection. We already know this. Reflection is when something bounces back, right? Okay, and so the rooster that's looking into his mirror, I guess it's his mirror or maybe someone's mirror, you're going to see something back. Okay. However, what you're going to see is probably going to be reversed, and we're going to see that in a second. Okay, because of another term. All right. So a lot of times when you have a reflection of whatever, light, okay, sound. All right. So when I go to the, I can hear myself. You know, I'm kind of loud anyway. You can hear me in the hall. It kind of bounces back. Okay, because my door's open right now. So with this, that's going to be something that a lot of these, either mechanical or electromagnetic, you can have things bounce back. And that's why they have sonar. That's why they have bats and dolphins and stuff use echolocation. It's pretty cool. Okay, now this video is always very interesting to me. Okay, refraction is what happens when a wave goes through something and bends. Okay, if it's going from air to water, if it's going from water to air, if it's going from gas, or we already talked about that, from solid to whatever, okay, you have that bend. And a lot of times we would use light crystals, and I'd show you and watch how if I shine the laser through it straight, it would go off to the side. It's pretty interesting. Okay, but when you fill this up with water, it actually flips the image. Okay, and even though I know it's going to happen, I'm still like, hey, look, it's pointing in different directions, guys. It's pretty awesome. Okay, one of the last ones that we're going to look at is diffraction. Okay, diffraction is diffraction is a very simple setup. Okay, and it is going to be something that is going to be basically the bending of a wave. And what happens is when you have diffraction, okay, diffraction is basically going to be, can split things up. So if you have the special glasses, and we have some here, I wish we could do this lab, but what white light actually splits up into all the colors that are on your screen, okay? And that's because of the bending. So we will look at it, we will talk about it, but for the most part, that's the basics. Now, interference, okay? If you have noise canceling headphones, all right, or if you have AirPods, or if you have whatever, they actually have technology in them, some of them, not all of them, that actually cause what is called wave interference, okay? Wave interference is basically, let me show you this. Well, and this video that's up at the top, or the GIF or whatever it is actually really does a good job of it. But let's say there's sound outside where your ears are that's doing that, right? Well, the best noise canceling technology will actually make a sound that's doing this. And what that does is it cancels it out, and it basically makes things more quiet. So they've done research on these types of things, okay? And they figured out what sound makes, if it broadcasts it, makes things quieter, okay? So it's actually really interesting. I think it's interesting, all right? And we use these things in a lot of technology, all right? So that's basically what we have today. Now, whoops. What we're going to look at, oh, I had this open already, okay? You guys have a couple of things to do, okay? And they were asking me last period about, hey, can you tell me what I'm missing? Yes, watch. Okay, so if you go home, let me go to student view so you can see it. Okay, if you click on grades, you can tell Mr. Kuhn has been a terrible student this semester. Look at this. Okay, and so if it's missing, that means you haven't turned it in yet. Or if there's an X, that means it's incomplete. Okay, and remember, even the incomplete stuff, you can get it may be part of your weekly grade or something like that. So you got to have all check marks and all high grades. Okay, so if you have something with an X or you have something with a 0, you have to go through and do that. Okay, and here's the stuff that we've gone over. So that's a really good way when you have time today, okay, to go through and look at and see. The other thing, let me go back. The other thing is when you, well, I'll just tell you since it's acting funny. Okay. You can actually click, if it says you have a 0, you can click that actual thing and make it a, you can pull the actual assignment up. Okay. Now, what we're going to do is, first off, you're going to be doing that. But also, before you leave today, 1,000,000% you need to put in the chat the second part. Okay, so this was the second part of your stuff today. Okay, now, ideally, you should have already told me what the 3 things you think are going to appear are. Okay, we already went over them. We talked about a few things. So this is even more important. Okay, and this is a really big time study tool. If you can figure out what type of question I'm going to ask you, I bet you're going to be really successful tomorrow. So for each of those 3 things, you need to tell me what kind of question you think I could ask. Okay, if you said force, then guess what? We're going to do such and such and such and such. All right, we need to make sure that we are paying attention to that. And also, this video is really cool if you want to watch that. All right, now you have a number of things that you can be doing. Okay, and I will be responding to any questions, comments, or concerns in the chat. All right, let's go ahead and get started. And we're going to get back together at probably about like 1:15. All right, let's go.